Hey Samantha, this is Mr. Caslin. I want to talk about these half-life problems. These are not easy, but there's a certain procedure to them, and I think once you understand the procedure, they won't be too bad. All right, so we're talking about things like fossils and how long they've been on the Earth, and so we know that they decay at a certain rate. Okay, these rates are not linear; they're exponential decay, so there's a curve to them, and we're trying to figure out how long certain materials, how long it's going to take them to decay. Anyway, so think of half-life as how long, how many years does it take for half of this object, such as this fossil, to decay. So this is our formula. Now it's just a matter of understanding these variables. All right, so think of this as the initial amount of whatever it is, such as your fossil. Like how much did it weigh? Y is your final amount. All right, and T is the time it's taking to decay. Now B is a constant. It's just for certain different types of material, different radioactive isotopes, they're going to have a different rate of decay. So this B controls what your rate is. Okay, so think about this problem, what they've told us. They've told us the half-life, okay, the time it takes for half of the material to decay. All right, so you're going to use this half-life, in almost all of these problems, you're going to use the half-life to figure out what B is first, okay? Because the fact that it's a half-life, we know what the initial quantity of the material is, and we know what the final quantity for half-life. Okay, what I mean by that is, if we know that you have a half-life of 1,599 years, so that's gonna be our T in this problem. Okay, and it was the amount of time it took for the material to decay in half. All right, because of that fact, we can call our initial quantity 1 and our final quantity 1/2. Okay. Okay, so think about that again. Our half-life, it took 1,599 years. So if we set the initial quantity to say, for some 1 gram, we know we had a half a gram left. All right. So just memorize this pattern as your first step in these problems. Take your half-life, and what we're doing is we're trying to figure out what this constant B is, because they did not give us B in the initial set of information. Okay. When you multiply anything by 1, that's the same as just 1 times anything is just itself. So think of this as 1/2 is equal to e to the negative b times 1,599. All right. So you have a exponential here. All right. You're solving for b. All right. Remember, you take the natural log of both sides to get rid of the e. So you're going to work this problem, and you're going to find out what this constant is. Okay, the constant is going to be a very small number. Okay, I'm not going to solve it for you, but I'm going to, it'll look like something like 0.000123. That's not the exact answer, but it'll look something. It'll be a very, very small number like that. Okay, so again, to reiterate, the first thing you want to do in a problem like this is take the half-life information and find out what the constant is. Okay, so you're going to solve for B. So now we know what B is. Now we're going to go to part two of this problem. Should have made my eraser a little bit bigger. Okay, part two of this problem is, what are they asking for? The initial amount or the final amount, the amount after 1,000 years. Okay, so we're looking for the amount after 1,000 years. So, oh no, we want the initial amount. Oh well, sorry. Instead of rewinding the video and trying to make my explanation perfect, we'll just move on. Let me go back. We have to go back and see what the problem is asking for. It tells us the amount after 1,000 years, and we want the initial amount. Okay, that makes sense. All right, so we're going back to this formula now, filling in everything we know. We know that the final amount is 0.35 grams. We're trying to find the initial amount. E is our base. Our B is the number that you're going to plug in. Remember, I didn't calculate this exactly. You need to calculate the exact number. So you're going to put in B. I'm going to use just this number I made up just as an illustration. And how long did it take to get to 0.35 grams? Remember, it took 1,000 years. So this time our time is 1,000. Okay, so now you have one of these exponential equations. You're solving for A. All right, so this part here, you can use your calculator, change this into a decimal. So it's 0.35 divided by the rest of this. All right, so step one, use your half-life to solve for B. Once you get B, plug it in, and in this particular problem, you're solving for the initial amount of material you had, which is A. Okay, hope that helps. It's just understanding these variables is the hard part. Y is always the final amount of your material. A is the initial amount. T is your time, and B is this constant. And again, this constant is not going to be given to you in most cases, so you have to take step one, use your half-life to figure out what the constant is. All right, I'll create a separate video to talk about the second problem. Thanks.